Hi students, in this video we are going to discuss about these problems. I'll read the question now. Express the following in the form of a plus ib. It means that these problems final answer should be written in the form of complex number. Now we will see each problem one by one. Now the first question is, if you observe the first question, this is a complex number minus another complex number. It means that the second complex number is subtracted from the first complex number. We already learned how to do the subtraction in complex number. Real part should be subtracted from real part and imaginary part should be subtracted from imaginary part. So in this problem what we will do is 1 by 5 minus 4. That means real part is subtracted from real part plus iota times of imaginary part, that is 2 by 5 minus 5 by 2. After doing the simplification, we will get the final answer in the form of a plus ib. Now you can observe it. Real part is subtracted plus iota times of imaginary part. They are subtracted and we got the final answer. Now we move on to next question, that is 3 into 7 plus 7i plus iota into 7 plus 7i. What we need to do is, first we must remove the bracket. Hence, in order to remove the bracket, we can multiply this 3 inside this bracket so that we will get 21 plus 21i. Similarly, this iota can be multiplied inside the bracket. We get 7i plus 7i square. We know that I square can be written as minus 1. So it becomes minus 7. After that, real part will be added with real part. Imaginary part will be added with imaginary part to get the final form of this. So if you observe it, after multiplying this 3, we get 21 plus 21i plus iota is multiplied inside the bracket. We get this expression. Now if you observe it, this is a complex number plus another complex number. Two complex number added by adding the real part with real part and imaginary part with imaginary part. So 21 minus 7 gives us 14 plus iota times of 21 plus 7, 28i. Hence this is the final answer. I hope you can understand the second problem. Now we move on to third problem. In the third problem, 5i is multiplied with minus 3i. First I and I can be multiplied. It becomes I square. I square is minus 1. So minus 1, already here minus sign presents. So minus 1 into minus sign becomes plus. And then 5 can be multiplied inside the bracket. So 5 and 5 will get cancelled. We will get plus 3 as an answer. You can observe this. Now we move on to next question. As you know, here if you observe it, minus I is multiplied with 2i and then the result is multiplied by minus 1 by 8i whole cube. Now we will bring this cube here. So minus 1 by 8 whole cube and I cube. So we get minus 1 divided by 8 cube is 512 and then I cube. We know that I cube value is minus I. So minus into minus will become plus. Plus I will be there, and then if you multiply these two terms, minus I into plus I becomes minus I square. We know I square value is minus 1. That minus 1 is multiplied with this minus sign, so it becomes plus 1 into 2 becomes 2. Hence we can simplify that like this, 2 into, then if we multiply these two, we will get this final answer. I hope you can understand this problem. Now if you observe this fifth problem, this number is multiplied by this complex number. Like polynomial multiplication we can do, otherwise algebraic multiplication we can do. Minus root 3 can be taken. It has to be multiplied with each and every term of this. So minus 3 into 2 root 3 is minus root 3 into root 3 becomes 3 and then 2. So 3 into 2 6 minus 6 and then minus root 3 will be multiplied by minus I. So it becomes plus root 3i. Similarly, this square root of minus 2 can be written as minus 1 into 2. In place of minus 1 inside the square root, we can put I square. That can be brought outside the square root. So we get I into square root of 2 and then it can be multiplied with each and every term. If you observe this, based on the algebraic multiplication we can do it, we will get the final answer. I hope you can understand this problem as well. Now if we move on to the sixth question, one complex number is divided by another complex number, we already learnt the procedure that we should not have in the denominator we should not have a complex number. Hence conjugate of the denominator should be taken and it should be multiplied with numerator and denominator, so that we will get the final answer. If you observe it, the conjugate of 1 minus root 2i is 1 plus root 2i, hence numerator and denominator is multiplied by the conjugate. So in the denominator, if you observe it, a minus b into a plus b is there, so we can use a square minus b square formula, hence 1 square minus root 2i square. So when we do the square, we will get 2i square. I square value is minus 1, that can be multiplied with this minus 1, so it becomes plus 1. And in the numerator, 5 should be like a polynomial multiplication, we can do it. When we simplify this, we are getting this final answer. 3 can be taken as common in the numerator, 3 got cancelled, so they got the answer of 1 plus 2 root I. I hope you can understand all these problems clearly. These are the basic concepts that we already learned. Now we move on to next set of problems. Express the following in the form of a plus ib. It means that answer should be written in the form of complex number. 2y minus I square whole square. Already we learnt the formula for this, a minus b whole square. A minus b whole square means we can use the formula a square minus 2ab plus b square. That is what is used here. But what they do is here, they are converting this I square as minus 1. Minus 1 into this minus will become plus 1. Now they apply a plus b whole square. Even if you apply here a minus b whole square, we will get the same final answer. Here they converted this I square as minus 1 and then they simplified it. Now they apply a plus b whole square. A plus b whole square means a square plus 2ab plus b square. When we write it, we get this expression, and then we know that I square value is minus 1, and then minus 4 plus 1 becomes minus 3. This 4i will be written as it is. If you observe it, the final form is in the form of a plus ib. Now if you observe the second question, we can consider minus 2 as a minus I divided by 3 means b. So we can apply a minus b whole cube formula. A value is equal to minus 2, b value is equal to I divided by 3. So a minus b whole cube, a cube minus 3a square b plus 3a b square minus b cube, and then they simplify it. Minus 2 cube is minus 8. If we multiply, minus 2 whole square is plus 4. Plus 4 into minus 3 is, this 3 and 3 can be cancelled, so it becomes minus 4i. Here if you observe it, I square is minus 1 and in the denominator we get 9. I square is minus 1 divided by 9, so minus 1 into minus 2 will give us plus 2, and this 3 and 9 can be cancelled. We will get the corresponding value 3, and then minus I cube divided by 3 cube is 27. Now we can simplify this I square as minus 1. It can be multiplied here, so we will get this final answer. Now imaginary part should be written together, real part should be written together. Minus 8 plus 2 by 3 should be written separately, and then after taking iota as common, minus 4 plus 27 will come. After simplifying it, we will get the answer. Now if you observe this 1 minus I whole power 4, we do not have the formula for a minus b whole power 4. So what we will do is, this 4 can be written as 2 square whole square. So a minus b whole square and then again whole square. You can observe it. Now we can apply a minus b whole square formula. A square plus b square minus 2ab, and then this whole square is written as it is. I square is minus 1. Minus 1 plus 1 becomes 0. So minus 2i whole square. Minus 2i whole square is plus 4i square. I square value is minus 1. Minus 1 into 4 gives us minus 4. I hope you can understand this basic concept as well. With this, I am completing this video. In the next video, we will discuss some more problems related to operations of complex number. Thank you students. Thanks for your cooperation.